Hello everyone, welcome to this course on Data Science Foundation. My name is Anand Paul. I am a professor at Gyeongbuk National University, and today I am going to introduce this course on Data Science Foundation. So as the word data science these days it's becoming very popular, and you might have also heard about the word big data. Yes, it's no longer a buzzword, but still everybody is kind of crazy about these words and people like to be an expert in this area. But anyway, in this course we are just going to see some foundations, some very basics of data science as well as big data analytics. So to begin with, let me briefly talk about the data. What is data, or what is the word data means? We know that data is informations. It can be of any data type. And the word data itself, if you imagine like before 200 years, not many people use the word data. But for the last 50 years or so, the word data has been used a lot. And it has many variants. For example, today we have data analytics, we have data science, we have big data. There are a lot of other words that is related to the data. Database is another good one. So a lot of buzz around this word data, and that again leads to this data science term. Let's jump into the word data and let's see more about the big data itself. Well, coming back to the word data, in the early 18th century, back in England, there was a statistician, and he was quite curious about a prevailing disease at that time. And they took a lot of survey, and they took first-hand information, all handwritten information. And this data has been compiled, and finally they come to know that the disease spread not because of air, but because of water. Initially they thought it's because of the air, the prevailing air that in fact communicated the disease, but later they came to know that it's because of the water. And this conclusion was derived only after they had enough data in hand. Okay, let's move on. Yes, today we are with this word big data. Yes, big data means extremely large volume of data, and again, as the volume presents large computation complexity that you have, and it again provides a lot of challenges. Say for example, the variety in the data again gives us challenges in digging out the information from the data. In the past, the example that I gave you about writing out all the information about a prevailing disease, and they wanted to take out the needed essential knowledge out of this data. They do it manually. But today we have massive amount of data, and if you do it manually, it's kind of painstaking, and it's quite impossible in our terms to extract the knowledge out of the data, because we are not talking about a book of data, a book of information. We are talking about megabytes, gigabytes, terabytes, why not even zettabytes, exabytes. So these are huge volumes of data, and these data do need a way of processing. Yes, there is one statistics, it says that 90% of world's data was generated in the last 2 years. Just imagine that. Suppose we know that the world is there for a long time, and all these thousands of years we have collected data, probably just using various forms, maybe writing informations or drawing informations. All those stuff we did in the past. Of course, in the past we didn't have any sensors, but today we have the liberty of using sensors and collecting huge information. And moreover, who is generating this data? Yes, as you know that social media contributes a lot for this data. For example, like you have Facebook, you have Twitters, the huge and massive information has been spread throughout. Not only that, we humans have cell phones, and the cell phone itself has lots of sensors in it, and they can create a huge amount of data. Adding to that, the internet itself, if you just consider the YouTube, you can see how much hours of videos been uploaded every day. Yes, that's quite massive, adding to this overall growth of data in our day. So data in general, when people talk about big data, they generally talk about these three important V's, the so-called volume, velocity, and variety. As far as the volume is concerned, yes, we have huge volume of data in terms of terabyte, exabyte, zettabyte. Yeah, we have huge amount of data. Even before a decade ago, nobody thought that we would be talking about zettabyte today, but today, yes, things are getting reality. Even, for example, a smart home, the devices in the smart home can generate huge amount of data. If you collect all the data for a year, then that would be so massive. Just one house. And it is estimated that the airplane data, all the data that has been communicated to and fro to an airplane during its flight is again massive amount. Not only that, we have the speed at which the data arrives or leaves. Today we have the streaming data, and these streaming data are in motion. Yes, that's what we term as velocity. It is the data in motion. Then comes the variety. Yes, data has many forms: structured, unstructured, and sometimes we also have semi-structured data, text data, multimedia data, and so on. Well, initially we thought that this big data has only 3 weeks that would add up to volume, speed, and computation complexity. But later on, they come to know that there are lots of other V's. So we are not going to stop with 3 V's. There are more V's to it. Let's see one by one. Yes. So I will briefly explain to you about this 10 V's at hand, and then we'll see what are the other possible V's that could be added. The first one, as we have seen earlier, it's the volume or the scale. I have given here some information, some statistics for the data volume. As you can see here, global IP traffic from cloud data center in the year 2018, that is right now, is 10.6 zettabytes. And that's what you see in this graph there. There is this projection from 2016 onwards, and again you can see the expected projected data That's until 2021. Yes, it's keep on increasing. How about the other data like traffic data, traffic for data center to user worldwide? It's 1.61 zettabyte. How about data volume of global consumer web usage like emails and the net data traffic? There it is. That's 9,059 petabytes per month. Yes, just for your reference, you know that what is gigabyte, terabyte, petabyte, exabyte, and zettabyte. I have given here in this slide. You can have a look at it. Yes, that's the volume. We have huge volume of data. The next characteristics of big data is the variety. I have briefly explained to you what is that variety. Here we can see an individual, and this individual is surrounded by various amenities and various data that are associated with it. So we have text data, we have video data, we have, say for example, some numeric data, audio data. So all this data adds to the complexity of the problem at hand. Yes, sometimes even a single application, for example, if you are talking about weather in itself has various types of data. We might talk about humidity, you might talk about the precipitation, you might talk about particulate matter. Yes, they may have of different type, and the measurement in which you take these data are of different. You can't have the same scale, the scale varies. Yes, it again adds to the complexity of the data. Let's move on and see the next one. We talked about the velocity, right? Yes. So there is a project called Square Kilometer Array, and this project is located in Australia as well as in South Africa, and they have these huge antennas projecting towards the space, and they are receiving huge volumes of data, and this data comes at quite high speed. Yes, today we are generating huge amount of data. Yes, this huge amount of data is coming in a real time, and the complexity is that when it comes at a real time, we do have to process it in real time for certain applications. Like it may be a military application, it may be a health based application. So that's where the problem comes in. We may have to solve it so quickly. So here is this example, like healthcare monitoring system. Sensors monitors the body activity, and if there is an abnormal measurements, we have to respond to it quickly. And we know that these data are streaming right away. Then comes the veracity. Veracity means data in doubt, or in other words, it's kind of unpredictable content with no structures. We are not sure what is there in the data, or is this data really the one we needed, or is it complete? There is some kind of abnormality or ambiguity or deception. Yes, this may lead us to draw wrong conclusion. Sometimes this data in doubt may also refers to the noise in the data that can mislead us. Yes, we should be very cautious of handling such data. Then comes the valence. Well, when you talk about the valence, we always refer to the valence electrons. Yes, as the word valence suggests, it refers to the connectedness of the data, like in the form of a graph or so. For example, like maybe in a social network, two friends are connected to one another because they are friends. Or maybe you could say a city is connected to its country that it belongs. Yes, all the cities are connected because they belong to the same country. Yes, sometimes data are directly connected, like the one I mentioned, or sometimes they are indirectly connected. For example, like two students studying in a different university in a different country, they are connected because they are students, though they are not part of the same university or the same class. Still they are connected because they have the same category of students. Let's move on to the next type, the validity. Yes, validity in data collection means that your findings truly represent the phenomena you are claiming to measure. Validity refers to how accurate and correct the data is. So it's very hard to assume that data is consistent because it directly affects the quality of the data. Yes, validity. How do you validate the data? Well, we have the data, but this data really is the one that claims to be the one that we really wanted. For example, let me state an example. So you have a sales data, and in the sales data suddenly you find some abnormality. Say for example, like you have a sales of say tomatoes, you have 50 tomatoes every day, and then after a week you have like some 3 or 4 tomatoes, and this does not match with the remaining tomato sales throughout the year. Is there any abnormality, or this is because of another factor? Yes, we have to examine these things, we have to validate. Maybe there is a festival season, so it's a holiday, or maybe it's raining, so nobody came out to buy the tomato, something like that. You may have to check for the correctness of the data. You have to validate the data. Again, this validating data is again a part of research. Some people are still working on it. We can improve the quality of the data as well. If the data is not really correct, we have to make it correct. Maybe at times it's mixed with the noises, right? So if it is mixed with noise, then maybe you have to filter it out. Once you filter it out, the data is kind of valid, or in other words, it has some quality now. Then comes the vulnerability. Yes, as the word vulnerability suggests, it brings us with the security issues. Yes, even today we are hearing about a lot of website has been hacked, right? Not only websites, the smart homes have been hacked. It's been reported that someone spoke to the nanny in the house by hacking the CCTV that is installed in the house. Can you imagine that? Yes, it's happening. And even people hack the thermostat in a house. So sometimes it can be dangerous. Just imagine if somebody is hacking some implanted devices. We have many wireless implants made these days. Say for example, you have a insulin implant in a diabetic patient. How about that? If somebody is hacking, what happens? If we provide more insulin, or if we refuse to provide the insulin, it would be a disaster. Yes, that's a big issue. Security is a big issue when it comes to data science. The other part is about the privacy. Yes, sometimes as we talk about all types of data, most of the data is from us, individuals. Yes, the companies are using our data. In most cases, they say that we won't own the data. And if you want to get the data, in fact, you have to pay for the data. There are instances and companies, they claim the data is theirs. Where comes the privacy? Yes, whether it's about your social network. When I say social network, I mean the social media in which you are networking with people. Is that being monitored? Or are you happy to see someone is monitoring your movement? For example, if somebody else knows where your car has been parked every day, if somebody knows this detailed information, does that make us comfortable? Yes, these are some of the issues that we have to overcome. Vulnerability, it's really a big issue. The hacking and security concerns of data are quite a big issue that's been threatening us these days. And there are a lot of companies behind this data, and we know that the companies are still trying to handle the data, and they do try to provide solutions to these security issues, but still we don't have a secure system yet. Next comes the volatility. So we can call it as volatile, or whenever there is a system, the system would have a lifespan. How about the data? How long a data is valid? That's a good question, right? So for example, you are collecting the data of a, say, smart building, and you are storing all those information. Say for example, you have zettabyte of information has been stored, and you have been storing for years. And how long are you going to stay? Are you going to store 10 years, 20 years, 30 years, 40 years? Yes, there is a question of volatility, right? So this is one of the concerns that we have to address. Say for example, a dam has been built, and you are monitoring all the sensors in the dam, and it's been built for 100 years now. Do you think that you have to still save all those data that were stored before 100 years? Or do you want to just ignore or just delete those information? It's a critical question. Yes. So we have to weigh down and see the validity of the data. How long you have to keep this data as a valid one? That's another big issue at hand. This is another interesting part that data has brought us, since the data science is offering various analysis part. So visualization of data are getting popular these days. So we have various tools for us to visualize the data. For example, you have Microsoft Excel is one of the good tool. Then you have this Tabula, is again very popular tool for data visualization. And there are some business intelligence tools like you have Power BI from Microsoft. Yes, these are some of the tools, but you have still more tools ahead. So here's one example of data visualization is given to you. Okay, let's go to the next one here, the number 10. Yes, the number 10 V is the value. Big data should create value. Big data creates value. How? Well, we acquire the data from the sensors and other sources, say mobile, computers, social medias and sensors. We collect all those information. Then you do some pre-processing. Then analyze these data. After analyzing this data, you get the insight of the data. And from the insight, you are taking those values, those diamonds out of it. As there are a lot of areas in which the values could be made. Say for example, you have retail, consultancy, transportation, construction, automobile, industries, telecommunication, etc. Let me give you some example of how the values can be created. Say for example, you are monitoring some elderly person's health data, and this person is having various wearable devices, as well as he has some sensors and cameras installed in the place of his living. So continuously he has been monitored, and we use some machine learning techniques to understand what he is doing, or he, like for example, is he sitting on the couch, or is he cooking something, or did he just fall down, slipped, is he unconscious. We use various methods, algorithms to visualize this event, as well as we are continuously monitoring his health data that comes from his wearable devices. Suppose we try to a conclusion that something serious happened to this individual, then right away we can take action. A nurse or a nurse from a nursing home can go there directly, or an ambulance can be sent directly to give him some paramedics. Yes, it's life-saving. That's the value we talk about. Let me give you another example. Just imagine that there is a forest fire or wild fire. What happens once the wildfire starts to spread? Yes, it consumes thousands of acres of forest. Not only that, it also comes into the neighborhood, and then some properties that's on its way is also consumed. Adding to that, it creates a lot of smoke. That's not good for the environment. What if we have sensors in the wild forest? Yes, the sensors can pick up the signal, the heat signals, and they can give us an early warning. And once we get the early warning, we can give this information to the fire brigade, and the fire brigades, they can act immediately to extinguish this fire. So this extinguishing this fire again creates a value. For example, you are saving the forest as much as you can, and you are also saving the properties that it would consume on its way, and sometimes you are also saving the lives of the wildlife as well as some individuals who might be trapped in this wildfire. As there are a lot of areas in which we can use this big data analytics, the insight, and then we can create a value. And it has been reported from an airline company. This company was monitoring this aircraft's parts, various different equipments being monitored, and accordingly they maintain these equipments. So they collect the data from these equipments and they maintain it accordingly, so that they don't have to replace these equipments so often. Because they are not replacing this equipment so often, in fact they saved millions of dollars. Yes, they are creating a value. Yes, the overall objective of the big data is to create some value. We have to get something out of it. If you're not really getting something out of it, it's of no use. When I say about value, I mean it should be something worthwhile, like life, time, of course the money. If you're saving the money, if you're saving the life, if you're saving time, there are a lot of values in these elements. Yes, I'm just going to stop with this 10 V's. In fact, recently I found that there are like 42 V's, and in fact we are heading towards 100 V's. Yes, probably you would come across 100 V's of this big data in the days to come. Yes, that's a simple introduction to big data. I'd like to talk more about the data quality as well as data reliability, and moreover I want to talk about some sentiment analysis, how the data are used to analyze these sentiments. That we can see in our next class. Until then, goodbye.